Okay. So numerical integration. So I have derived Newton Cotes quadrature formula. So what I have given is integral 0 to f of x dx. So this is given as n into h into y naught plus n by 2 times of delta y naught plus n into 2n minus 3 divided by 12 into delta square y naught plus n into n minus 2 whole square divided by 24 into delta cube y naught plus dash dash dash. So this is how actually Newton's Cotes formula was derived. Now in this actually, so this is ideally integral f of x dx from x naught to x naught plus nh. So this is the integral what we are talking about, which essential means for us is, suppose if there is a curve like this, and for this curve, if you wanted to find out the integral, and this integral value, let us say you started from here, which is the originating point as x naught, and then this was divided into n different intervals of same width. So this is how actually you have divided this entire region into multiple parts of equal width. So this is 1h, and this is h, this is h, this is h, and this is h, and this is h. 1, 2, 3, 4, 5, 6, 7. So this is x naught plus 7h. So in general, x naught plus nh. So this is how actually you are dividing this entire region for the integration purpose. Now in that actually, if you take one particular interval, so this interval, so this is x naught, and then the next one is x naught plus h. Now within this actually you wanted to find out the area of the curve. So the curve can be approximated as a trapezoid. So this trapezoid, now you are trying to approximate this as a straight line rather than a curve. So this is a straight line rather than a curve, and this straight line, it makes a trapezoid of side length this one and with a height of the horizontal length. So this h is the width for us, and then this is y naught and this is y1 for us. So as a trapezoidal rule, if you want to find out the area of this trapezium area is going to be of h into a plus b. So of h into a is y naught and b is y1. So of h into y naught plus y1 is the area of this trapezium. Now like this actually, all the parts actually, it can be approximated as a trapezium, and then you will still be able to find out the area of all the strips individually, and you can add it together so that you will be able to get the area for the entire region between x naught and x naught plus nh as an approximated area of trapeziums. Got it? So this one what we call is the trapezoidal rule, and this trapezoidal rule, for each one this is the area. Now for the second strip if you are talking about, then this is going to be h by 2 times of y1 plus y2, and the third strip is going to be h by 2 times of y2 plus y3. So like this actually, so whatever may be the number of intervals it is going to be, so like the last one is going to be h by 2 times of yn minus 1 plus yn. So this is the area. Now if you add all these things together, this is going to be y naught and yn comes only once, and rest of the values, this y1 and this y1, this y2 and this y2. So rest of the values are coming out to be 2 times. That means the area of this trapezium, so if you approximate as a trapezoidal rule, area is going to be h by 2 is common for entire thing, and then y0 and y1, yn comes only once, and rest of the values actually 2 times of, I'll put it here, 2 times of y1 plus y2 plus dash 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 yn minus 1. So this is the area of this entire region if it is divided into n different parts of equal area. Sorry, n different parts of equal width. Got it? So this is the trapezoidal rule. Now the same rule actually you can bring from the Newton's codes formula. So this one, let if n equal to 1. So if n equal to 1 from the Newton's code formula, then this is going to be, so this is going to be 1 integral f of x dx from x0 to x0 plus h. So this is going to be n is 1 and h is as it is, and then y0 plus 1 by 2 times of delta y0. So higher order terms are going to be not there. Why? Because, so as I said earlier, no data points, you are trying to approximate as a trapezium with 2 different sides. So here this is going to be h times of y0 plus 1 by 2 times of y1 minus y0. So this value is going to be, again, this is the same answer as h by 2 times of y0 plus y1. So even if you calculate as if like it is a trapezoid, or in Newton's codes formula, if you put n is equal to 1, the both the formulas are one and the same. Got it? I hope you understood this concept. Fine. So you can note down this. So in general, trapezoidal rule, if you are applying for the numerical integration, you can straight away write as integral f of x dx. So from x0 to x0 plus nh is going to be, straight away you can write as h by 2 times of y0 plus y1 yn plus 2 times of rest of the values y1 plus y2 plus dash 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 yn minus 1. Got it? You can note down this. Now in the second rule, which we call as Simpson's 1/3 rule. Now here actually what we are trying to do is, you are trying to approximate as a parabola rather than a trapezium. By that actually you will be able to better approximate the area. So even though if it is a curve. Now here actually if you take a random curve like this, in this you take this as the first one x0 and this one as the second one x0 plus h and this one as the third one. So here actually x0 plus 2h. Now if it is a straight line, then actually there is a different case. Now actually you are trying to approximate this as a second order polynomial as if like it is a parabola. So this is how actually a part of the curve is going to be a approximated parabola. Now here actually 2 different intervals are taken together. So 2 different intervals, this is h and this is h, 2 intervals taken together. For calculating one area. Right? So for calculating one area, you are taking 2 intervals together. So now actually when we are calculating, we will try to calculate the area of this entire region rather than one single part in case of Simpson's 1/3 rule. Now from the Newton's codes formula, so we have given integral x0 to x0 plus nh and f of x dx. So this one is nh by 2 times of y0 plus n by 2 times of delta y0 plus n into 2n minus 3 by 12 into delta square y0. Now I will stop here. Why? Because actually we are trying to take 2 intervals taken together. Here n is equal to 2. So here the integral value from x naught to x naught plus 2h. So 2h is giving two different intervals here. Now these two intervals together you are trying to approximate as the area. Now here this is the formula for two intervals taken together, and del square y naught will be there, and afterwards actually it won't be there because no data points for this particular region. We have considered only two different data points. So here this value is going to be f of x dx. So n is 2 and then h divided by 2 and then y naught plus 2 by 2 times of delta y naught. So delta y naught is y1 minus y naught plus 2 into 4 minus 3 divided by 12 into delta square y naught. So delta square y naught value, as I have explained with the help of binomial coefficients, you can start with this is y naught minus 2y1 plus y2. So this is the value of delta square y naught with the help of binomial coefficients, where it starts with, so these are all the binomial coefficients 1, 2 and 1, but starts with a plus sign and it continues to alternate signs. So plus 2 minus, minus 2 plus and plus 2 minus again. So like that actually it keeps on continuous for higher order dels. So this is 2 will cancel out and h times of y naught plus y1 minus y naught plus this is 4 minus 3 is 1 and this is 6. So 1 by 6 times of y naught minus 2y1 plus y2. So this is going to be h times of this y naught will cancel out, and then 6y1 minus y naught minus this is plus y naught minus 2y1 plus y2 whole divided by 6. So this is h by 6 times of, so this is y naught 6y1 minus 4y, so minus 2y1, this is 4 times of y1 plus y2. Sorry, this is nh, sorry. So this is nh. So here actually this is going to be 2 by 6. Yeah, 2 by 6. So now actually if you cancel this, then actually this is going to be h by 3 times of y naught plus 4y1 plus y2. So this is the formula for calculating the area for one particular, sorry, two different strips taken together, approximated as a second order polynomial, which we call as a parabola. So now actually if you consider the next values, so this is one section and this is another section. For these two sections, now this is y naught and this is y1 and this is y2 and this is y3 and this is y4. Now actually for the second strip, so this value is going to be for the second area containing two strips. Two strips actually from y2 to y3 to y4. So this area if you are calculating, then this is going to be, this is a1 and I call this as e2 is equal to h by 3 times of, so instead of y naught is going to be y2 and instead of 4y1 it is going to be 4 times of y3 then y4. So like this actually a3, and again a3 you can calculate as h by 3 times of, now this is actually y4 plus 4 times of y5 plus y6. So this is how a3 will be calculated. Like this you can keep on calculate all the areas and then you can add up all the areas together to get a single number by simplifying all these numbers. So first you note down this, I am going to simplify and put a single formula for that. So if you add it up together, h by 3 will be common across all, and then if you notice y naught is coming once, and then last term actually is again yn, which will come only once, and plus, and then if you notice the next one here if you notice 4 times of y1 and 4 times of y3 and 4 times of y5. So if you notice all the odd numbers are coming out to be 4 times. So 4 times of odd numbers y1 plus y3 plus y5 plus dash 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 yn minus 1. So 4 times of odd numbers. Again, if you notice the next one, here actually y2 is coming and here also y2 coming, and then here y4 coming and here also y4 coming. That means everything is coming as 2 different times. So that is y2, all the even numbers, y4 plus dash 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 yn minus 2. So all these values are actually coming out to be 2 times. If you notice, one important aspect in this particular Simpson's one-third rule is when you are dividing the number of intervals, it has to be always an even number. Why? Because you are bringing 2 areas together as a single number. So all the divisions has to be, or the number of divisions for Simpson's one-third rule has to be even number. So this is the rule for Simpson's one-third rule. Got it? Because you are considering 2 strips together. So this is the formula you can make use. And if you notice in all the formulas, right, so this y0 plus yn comes always as a single time, and rest of the values are going to be changed. Now here all the odd numbers actually are getting multiplied by 4 times and all the even numbers are getting multiplied by 2 times. Got it? Yeah, you can note down this. So this is Simpson's one-third rule. So now actually, in case of Simpson's 3/3 rule, sorry, 3/8 rule, the number of intervals for calculation of area are 3 together, 3 intervals together. And the curve is approximated as a third order polynomial. So this is approximated as a third order polynomial. Now here actually 3 different areas taken together at one instance. Now actually if you notice, so from here to here, this is treated as one particular area calculation. This is H, this is H, and this is H. And this is Y0, this is Y1, and this is Y2, and this is Y3. Now, till this point, actually, it is approximated as a curve, which is a third order polynomial, which can take more number of turns. Even if it takes more number of turns, still the area calculation will be very, very high accurate. Why? Because actually you are considering as if like it is a third order polynomial. Now, here, this is the area you are trying to calculate with the help of Simpson's 3/8 rule. So 3/8 rule, right? So here actually, it's not just actually taking 3 strips together or 2 strips together or 1 strip together. Here actually, in every formula, whatever we are going to derive, right? So the accuracy of the area is getting increased by considering this top part as a curve. So if you consider as a straight line, more error is going to be there. If you consider as a second order polynomial, so little lesser than the trapezoidal rule, error is going to be there. But if you consider as a third order polynomial, then the accuracy is still more. If you consider as a fourth order polynomial, accuracy is still more. But actually, in considering the order of the polynomial bigger and bigger, you are trying to take more number of strips together for the calculation purpose, because this formula demands to consider all those strips together. Got it? So here actually in the next one, so if you want to consider as 3/8 rule, this is so plus n into n minus 2 whole square divided by 24 times of delta cube y naught. So this is the formula that you need to be using in case of Simpson's 3/8 rule. So here again, if you substitute here, you are taking three different intervals together. Indirectly what it conveys for us is, when you are considering this area calculation, you need to divide this entire area into such number of strips where that has to be a number which is divisible by 3. So that means the last one, yn, has to be 3 times of some value p. So this is the rule. That means you are dividing into 3 different strips together for the calculation purpose. Now in such case, right, you have to divide the entire number of strips so that it is going to be a factor for 3. Got it? So here, if you apply x0 plus 3h together. So this is important. x0 plus 3h means these three taken together as one strip now. So this is f of x into dx is equal to, so 3 times of h plus y0 plus 3 by 2 times of delta y0 plus 3 into 6 minus 3 divided by 12 into delta square y0 plus 3 into 3 minus 2 whole square divided by 24 into delta cube y0. So this is the formula in case if you want to consider n equal to 3. So this one actually, if you further simplify it, this is going to be 3h into y0 plus 3 by 2 times of delta y0 is y1 minus y0 plus, so this is going to be 1 by 4. So 3 by 4 times of, so delta square y0 is going to be y0 minus 2y1 plus y2. And then plus, so this is 8 times and then 3 minus 2 is 1. So 1 by 8. By 8 times of delta cube y0 is y0 minus 3y1 plus 3y2 minus y3. So this is delta cube y0. So as I explained earlier, delta cube y0 is going to be first one. So this is actually, you need to write the binomial coefficients first. So that is 1, 3, 3 and 1. So these are the binomial coefficients, and then alternatively you have to put sign like this. So this is minus, this is plus and this is minus. Now here actually you start with y0 and it is going to be y1, it is going to be y2 and it is going to be y3. So this is how actually you can write delta cube y0. Similarly I have written for delta square y0 also. So now actually if you simplify this equation, so this is 3h times of, I think so you can simplify this and then put the final answer. If you notice here actually the right side part, so this one, that is y2 and y3. So if you notice, right, so y3 is ending there and here actually y2 is ending there. Here y1 minus y0 is there. So if you simplify, right, what happens is again y0 and the last one is going to be yn, it will come only once. But in between you are considering two different values here. So y1 and y2 also taken together and y3 also taken together, because in the entire formula you are using y0, y1, y2 and y3. So you have to write the equation for y0 to y3 first. So after simplifying this, you are going to get one formula. If you add 3 more strips again, you are going to get one more formula. If you add all these things together, then you are going to get a single formula for the Simpson's 3/8 rule. So first you note down this and try to simplify this. I will put the equation. So this is 3h by 8 times of y0 plus 3y1 plus 3y2 plus y3. So this is the simplified form for this area of A1. Similarly, A2 is going to be 3h by 8 times of, so 3h by 8 times of, now instead of y0, it is going to be y3, and instead of 3y1, it is going to be 3 times of y4, plus instead of 3y2, it is going to be 3 times of y5, plus instead of y3, it is going to be y6. So like this, actually, these formulas keep on coming. Now if you add all these things together, you are going to get a single formula. First you note down this, I am going to write that formula. Okay. So now actually, this simplified formula for Simpson's 3/8 rule is so area is equal to integral x0 to x0 plus nh, where n is equal to 3 times of p. So this is the rule. Now f of x dx is equal to, so this formula 3h by 8 is a factor, and then y0 plus yn will always be there. And if you notice, the factor of 3, y3, y6, y9, like that, actually it is coming twice, and rest of the values are coming thrice. So that is plus 3 times of y1 plus y2, and then next one are going to be, leaving 3 aside, you will be getting y4 and y5. So here actually y4 and y5 is coming thrice, and then next actually y6 is coming, but y6 actually it will continue for the next area, hence actually this is going to be y7 plus y8, like this it keeps on continuous up till yn minus 1, and plus 2 times of all the factors of 3. So this is how you are going to get the area for Simpson's 3/8 rule. So these are the 3 different formulas, so which we can make use to calculate the area of the any random number given, right? But the most popular one is Simpson's 1/8, so Simpson's 1/3 rule. Got it? So that is most popular because actually, so that gives a reasonable accuracy with less calculations. So that's why actually we stick to Simpson's 1/3 rule mostly for all the engineering calculation purpose. Got it? So you can note down this. Okay. So note down one formula, sorry, note down one problem. Evaluate integral 0 to 6 dx by 1 plus x square using trapezoidal rule, and the second one Simpson's 1/3 rule, and the third one is Simpson's 3/8 rule. So this one actually he has given as a problem statement integral 0 to 6, which essentially means that in trapezoidal rule you are dividing into the number of equal intervals. So that is depending on your accuracy requirement. You can divide into 12 intervals or the 6 intervals or the 18 intervals. Maybe it is always better to divide in terms of a factor of 6. So, but it's not a rule. So you can divide into any number of equal intervals in case if you wanted to use the trapezoidal rule. In case if you wanted to use Simpson's 1/3 rule, then still actually you can divide this 0 to 6 range into any number of intervals, but it has to be an even number. If you want to use Simpson's 3/8 rule, you can divide into any number of intervals of your own interest, but it has to be a factor of 3. Got it? So it has to be divisible by 3. So that is the requirement. Now here, if you are using trapezoidal rule, now actually we can divide this into equal intervals of 6 intervals starting from 0. So this is taking a random curve like this, and this is going to be, so this is going to be 0. So x is equal to 0, and then x is equal to 1, and x equal to 2, and x equal to 3, x equal to 4, 5, and 6. So this is 1h, 2h, 3h, 4h, 5h, and 6h. So 6 different intervals actually we have divided this. But actually this curve is a random curve I have given. It's not a curve of 1 by 1 plus x square. This is a random curve I have given for the explanation purpose of these intervals. Now here, so this table actually we can prepare by calculating the corresponding values. So that is, this is x value and this is f of x value. So f of x value is 1 by 1 plus x square. So if x equal to 0, then this is going to be 1, and if x equal to 1, then this is going to be 1 by 2, and if x is equal to 2, then this is going to be 1 by 5, and 3, 1 by 10, and 4, this is 1 by 17, and 5, 1 by 26, and 6, so this is going to be 1 by 37. So these are the intervals. Now here actually x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, 4, 5, and 6. So this is how actually you can calculate the values. Now actually these values actually, so this is I think monotonically decreasing function. So this is how the curve is going to be there. Yeah. Okay. So that is the curve. Now here actually if you are using Simpson's so if you are using trapezoidal rule, then the rule is integral f of x dx, integral 0 to 6. So this value is going to be now h by, so h into y0 plus y6 plus 2 times of rest of the values, y1 plus y2 plus dash 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 y5. So this is the trapezoidal rule. Yeah. H by 2 times of. Yeah. Okay. So this is the formula for the trapezoidal. Now actually you can substitute these values. So integral 0 to 6 f of x dx is going to be, now the h value is being divided into 6 different intervals for a range of 6. Then h is going to be 6 upper limit minus lower limit by total number of intervals is going to be 6. So this is 1. So if you divide this into 12 different intervals, then actually, so this one 6 minus 0 divided by 12 is equal to 1 by 2. So this 1 by 2 if you are putting, then actually you have to calculate the values for each 1 by 2. So 0, 0.5, 1, 1.5, 2, 2.5, like that you have to calculate for all the entire table. Now, if you calculate more number of intervals, the accuracy is going to be definitely more. But if you calculate less number of intervals, then the accuracy is going to be less. So, but actually you take for calculation purpose what is the reasonable value of h, so that actually without compensating on the error, right? So you should be able to calculate with less effort. So that is the criteria which you need to select. So here in this case, you can select as 6 different intervals so that our calculations are very, very easy. Got it? So h is equal to 1. Now you can replace it here. Then 1 by, so area with trapezoid, h is 1 and 1 by 2 times of y0 is 1 plus y6 is 1 by 37 and plus 2 times of rest of the values are 1 by 2 plus 1 by 5 plus 1 by 10 plus 1 by 17 plus 1 by 26. So these are the values. So whatever the value you are going to get it, so that is the area of this curve 1 by 1 plus x square. I think so this value is coming out to be 1.4108. This is the area. Got it? Understood the trapezoidal rule? Done? Now coming to Simpson's rule. So Simpson's 1/3 rule. So here actually let us take this 6 being a multiplicative factor of 2. Then actually these number of intervals you can still use even for the Simpson's 1/3 rule, because this 6 is divided by 2. So 6 is divisible by 2. Then actually you can make use of Simpson's 1/3 rule, because you can take two different intervals taken together as a single area. Now in that case, so this area formula is going to be area with Simpson's 1/3 rule. So this is going to be, so h by 3 times of y0 plus yn plus 4 times of y1 plus y3 plus y5 plus 2 times of y2 plus y4. So this is Simpson's 1/3 rule. Got it? So here h is again 1 by 3 times of y0 value is 1 and yn is now y6. So this is y6. So y6 is 1 by 37 plus 4 times of, so now actually odd numbers are 1 by 2 plus 1 by 10 plus 1 by 26 plus 2 times of even numbers. So 1 by 5 plus 1 by 17. This is the area with the help of Simpson's 1/3 rule. I think so this number is coming out to be 1.3662. This is the area of the region identified by 1 by 1 plus x square when it is divided into 6 different intervals with the help of Simpson's 1/3 rule. If you notice in trapezoidal rule, it is coming out to be 1.4108. Now here actually in case of Simpson's 1/3 rule, this is 1.3662. But ideally trapezoidal rule, right? So that depending on the curve nature, right? So it is going to be more or less, that we don't know. So how it is going to be more or less is, suppose if the curve is like this, and then trapezoidal rule you can approximate as this way. So here actually there is some area which was missed out. But actually suppose if the curve is coming out to be like this, and then this is 1 point and this is 1 point. Now this is the area. Here actually this extra area is getting counted. So hence this extra area is getting counted. Ideally it shouldn't be counted. In such cases the area that is coming out to be more than the actual value. In this case, as the so area is more, but actually ideally we are not counting the 100% area. In this case, suppose if the curve is of this particular format, then this area is getting missed out. So this part of the area is getting missed out. So hence actually in this case the area whatever you calculated is coming out to be less than the actual. So if this is this type of curve, then the area is calculated more, ideally it should be less. Here area calculated is less, ideally it should be more. So depending upon the type of curve actually the trapezoidal rule, whether it can give more value or the lesser value. But in case of Simpson's rule, what we are trying to approximate this as a parabola itself. So the error that is going to come in case of Simpson's 1/3 rule, whether it is a top curve or a bottom curve, in both the cases actually it is going to be less, because you are trying to approximate as if like a parabola like this, and in this case downward parabola like this. So the accuracy is getting more, hence actually this area is more closer to the accurate value. And if you consider the Simpson's 3/8 rule, the area is going to be still far better than what is Simpson's 1/3 rule. Got it? You can note down this. Now the same thing, if you want to calculate with the help of Simpson's 3/8 rule, then actually it is going to be A is equal to 3/8 times of H, and then y0 plus yn or y0 plus y6 plus 3 times of rest of the values including the factors of 3. So that is multiples of 3. So this is y0 plus y6, and then here y1 plus y2, and y3 won't be there, and y4 plus y5 will be there, and then plus 2 times of the, so multiples of 3, y3, and then y6 we shouldn't consider, y6 is already considered here. Got it? So this is how actually you should be calculating with the help of Simpson's 3/8 rule. So this area is going to be 3/2 times of H is 3/8 times of H is anyway 1, and then y0 value is 1, and yn value is 1/37 plus 3 times of y1 is 1/2 plus 1/5 plus 1/17 plus 1/26 plus 2 times of 1/10. So this is the area. So if you notice, when we considering here, right, so 3 different areas are taken together for Simpson's 3/8 rule. So 2 sets of 3 strips together. Got it? So this area is coming out to be 1.3571. Got it? So in this case actually trapezoidal rule gives more area, and Simpson's 1/3 rule is giving lesser than trapezoidal rule, and 3/8 rule is giving lesser than the 1/3 rule. So that means this is actually keep on reducing. So here actually, so here whatever the function we consider, right, 1/1 plus x square, so this is monotonically decreasing function. So that's why actually it is considering more area. So monotonically decreasing function is, so like this actually it keeps on comes out. Got it? So this is how actually you can calculate the area. Now actually in other cases actually, suppose if you consider monotonically increasing function, then actually the area calculation may be trapezoid may be less, and Simpson's 3/8 may be more, and Simpson's 3/8 may still be more. So but actually there is no relation that between all these things. That depends on exactly on the nature of the curve, how it is turning. So that's why there is no rule that, or there is no relation between the areas calculated by this. So Simpson's 1/3 rule or the 3/8 rule or the trapezoidal rule. So you cannot directly correlate the areas between these two. But actually accuracy you can correlate. Accuracy is the highest among all the 3 rules is 3/8 rule, and the next one is 1/3 rule, and the next one is the trapezoidal rule. So that is the least accurate value you consider here, it is the trapezoidal rule. But the quantity of area, whatever we calculated, may be more or less depending upon the nature of curve. Got it? Understood? So this is how actually you can calculate the numerical integration with the help of this Simpson's rule. Any questions on this? Any questions on this? So if no other questions are there, then I'm going to stop the class for today. In the next class actually I'm going to deal with Gaussian quadrature formula, and then if time permits we will continue with the numerical differentiation. See, as I explained earlier, right? So area, whether it is more or less than the accurate value, is always dependent on the nature of the curve. So if the curve is of this particular format, then actually, so I'll draw better. See this, suppose if you are using trapezoidal rule, if this is the curve, then this is one point and this is another point, then actually you are trying to approximate this curve as a straight line. Now obviously this entire area under the curve, actually if you consider it, that is the accurate value. But actually you are considering it as a trapezoid. So ignoring this area. So this is ignored. If it is ignored, then actually the area calculated is lesser than the actual value. Suppose if you take another curve this way, and then this is one point and this is another point, and then you are trying to approximate as a trapezium like this. Now here in this case, this area, ideally you shouldn't be considering it, but you are including this area also in your calculation purpose. Hence here actually, so this is more than the actual. And this is less than the actual. So this is actually purely dependent on the nature of the curve. But the accuracy relation is 3/8 1/3 rule trapezoidal. So this is a standard rule, because actually you are complicating the expressions for accuracy purpose here. So but actually nature of curve actually will give the actual area is more or the calculated area is more. That purely depends on this particular curve nature. Got it, Pankaj? See, Akhil. So by rule actually, or by definition actually, what we are talking here it is, if you wanted to apply 3/8 rule, it's a must that you have to divide as a multiple of 3. Otherwise you cannot use it. Got it? So for accuracy purpose actually you are dividing that into 3 different intervals taken together as a single area by considering as a curve. So you have to divide the number of intervals, otherwise you cannot use it. Even the same case with the Simpson's rule also. So you have to divide it into as a multiple of 2 only to divide the area, so that actually you can consider as a Simpson's 1/3 rule. So by taking 2 areas taken together, so that is a must rule. For trapezium, you don't need any kind of rule there, because actually each interval you have calculated separately. So that's why actually if you wanted to use Simpson's rule, you divide into 2. If you want to use 3/8 rule, you divide into 3. And if you wanted to use 3/8 rule, but you don't want to divide into 3, then actually it's not possible. Got it? You shouldn't do that. Yeah. Any other questions? So that's all for today. Yeah. Thank you. Good night.